This one is classified paper 2, topic 4.2, the electrical quantities. In this topic, you will find the questions related to current, voltage, and the resistance. The first one is related to electrostatic charging. We have an uncharged metal sphere is placed on insulating support. A positively charged rod is brought close to the sphere and does not touch. How do the charge in the sphere move, and what is now the charge on the sphere? Look, we did not earth. So if we bring a positive charge rod, negative charges will be on the right and the positive charges on the left. And always remember that positive charges cannot move. Why? Because what it actually happened when it is a neutral sphere. So the lattice of the positive ions, so there's a lattice of the positive ion and the delocalized electrons. Electrons are free to move. So the moment we bring a negative charge or a positive charge rod, what will happen? Majority or most of the negative ions are attracted, so they will move towards the positive, but the positive ions never move. So the movement is there for the negative ions only. The movement is there for a negative charges to the right of a sphere, but overall sphere, this overall sphere will remain neutral. Like if it was having 10 positive and 10 negative before, right now it will remain 10 positive, 10 negative. The only difference is it created a distribution. It will get charged if we connect an earthing wire. So if an earthing is connected, in that case the electrons will move and it will make overall negative. But without earthing, this sphere is still neutral, but due to the presence of the charged rod, it created a distribution of the charges within the material. Is it clear? This one, the first one. Any doubt in this?
No, sir, clear.
Okay.
Clear.
In question 2, a student rubs a plastic rod with a cloth. For example, if this is a plastic rod and student rubs with a cloth, the rod becomes positively charged. So this rod become positively charged. So if rod become positively, the cloth will become negative. So what happened to the rod? Because it is positively charged, so when something becomes positive charge, it must lose electron. So electron jumps from the rod to the cloth. So rod is losing electron and the cloth is gaining electron. So because it lost electron, proton is not an cannot move in within the structure like an atom. Atomic state, yes, it can, but not within the structure. The electrons can only move, and because it's a positive charge, that's why electrons are lost. Electrons are lost. And if it was a negative like charge, then it will gain electron. So whenever something lose electron, it will turn positive. An isolated metal sphere is positively charged, and we bring, so what charge will be here? The negative charge will be on the left and the positive charge will be there on the right. And as I mentioned, positive charges never move. Only what it created a distribution, like the negative charges move towards one end, so it appeared the positive are on the other end. So positive charges does not move, the negative charges move through the structure. In question 4, a negative charge plastic rod is put near an uncharged metal sphere. So we have an uncharged metal sphere, and near this metal sphere, we bring a positively charged rod. So what will happen? The electrons will move, the negative charge move towards one side, and the positive will move to other side. What happened when the metal sphere is earthed? So if we connect an earthing wire, so if we have a positive charge rod and we connect an earthing wire, in that case, what will happen? The electrons will move in. Means the net charge on this will be negative. So electrons will flow from the For this one, electrons will not flow from the metal sphere to the earth. The electron will flow from earth to the metal sphere. B should be the right answer. I will do correction for this because usually sometime as I'm marking. So B should be the right answer, that the electron will flow from earthing to the metal sphere. If we bring a positive charge rod, but in the question we did not bring a positive charge rod, we bring a negative charge rod. So if we bring a negative charge rod, in that case opposite will happen. Because the first example I was giving, that was if we bring a positive charge rod, but now if we bring a negative charge rod, it created a distribution positive on one side, negative on the other. And when we connect an earthing wire, the negative like charges repel each other. So negative and negative repel, so this will force the electrons to move out. So as an electron will move out, this time the electron will move from metal sphere to the earth. So if you bring a negative charge, metal sphere to earth. But if the same question and they changed the positive charge, in that case it will flow from earth to the metal wire, metal sphere. Is it clear? Any doubt in this?
No, sir, clear.
Okay.
No.
Then the diagram one shows a two thin uncharged metal strip, and the same strips have been rubbed with a dry cloth. So because it means they have the light charges because they're repelling each other, pushing each other. So the charge, if it is positive, this will also be positive, or if this one is negative, this will also be negative, as light charges repel. The charge on the strip will be same, they will have identical charge, and they will repel each other. That's why option D is the right answer. In question 6, a metal sphere is charged by induction. So if we want to charge by induction, what are the stages which we should follow if you want to charge a metal sphere? So first, a charge rod is brought near, so we should bring a charge rod. Can be a positive or a negative. So when we bring any charge rod, deposit, this will create a distribution of the charge within the sphere. Then what we should do, we should connect an earthing wire. Second thing, we should connect an earthing wire. The first one, we should bring a charge rod. Then when we connect an earthing wire, like electrons, in this time electrons will enter. So mostly it will be negative charge. Then what we should remove first, we should remove the earthing wire first, because if we remove the charge rod, then the electrons will go back to the earth. So we should remove the earthing wire first. The electrons connection is removed, they cannot move. And then at the last, we should remove the charge rod. So the order, first, a charge rod is brought near to the sphere. Then the sphere is earth, we connect an earthing wire, and then we remove the earthing wire, and then we remove the charge rod. So B will be the right answer. That was question 6. What is which quantity is measured in coulomb? So charge is in coulomb, current is in ampere, EMF is in volts, and power in watts. The conventional current, the direction of a conventional current from positive to negative, and electron flow from negative to positive. So positive terminal to the negative and negative to the positive. That's the direction of the electron and the conventional current. In question 8, in question 9, the diagram shows a circuit containing a DC power supply. So this is a DC power supply. Now, 3 ammeters are there because they're all connected in series. In series, the current is same. So if 4 ampere is passing through X, the same 4 ampere will pass through a variable resistor. Same 4 ampere will pass through ammeter Y. Same 4 ampere will pass through electrical motor. Same 4 ampere will pass through ammeter Z and return back. So the reading on X and Y will both, that will be 4 amp because they're connected in series. So in series, the current is same. In parallel, the current divides. Student uses 4 ammeters. Which ammeter read the largest current? Ammeter. So because the total current which enter, like maybe you can take any number, say 6 ampere is entering. So 6 ampere enter. If they are identical resistor, 3 ampere will pass through the first one, same 3 ampere will pass through the second one. And then it will rejoin again. So 6 ampere and then 6 ampere will return. So same amount of the current leave and enter the circuit. So P and Q, A will be the right answer. Is it clear? These questions?
Yes.
So these are some questions from electrical quantities, the topic 4.2.